In this video, I'm going to give you some examples of continuous functions and find their domains where they're defined or well defined. Let's start off with the very basic polynomial functions. So let's call it example 1, polynomial function p of x. Let's make up a polynomial function, let's say negative x to the power 17 plus 5x to the power 5 minus 7. This is a polynomial function. Now remember, there is a theorem. It says that polynomial functions are continuous everywhere on the number line. That means this function will be continuous on the entire number line, which will be from negative infinity to positive infinity. If I were to sketch it, it's going to be 0, 1, 2, negative 1, negative 2, and it keeps going. So the entire number line where this function is continuous. The next example I want to consider is this, example 2. Let's call a function f of x is equal to maybe x cubed minus 3x divided by maybe 5 plus x squared. Now this function is a rational function. It's a function where we are taking one polynomial, which is the numerator x cubed minus 3x, and dividing it by another polynomial, which is the denominator 5 plus x squared. Now when there is division involved, you always need to keep in mind that you do not divide by 0. So you look at the denominator, okay? You look at the denominator expression and see, is there any value of x that is going to make the denominator 0? In this particular case, the answer is no. Look, 5 plus x squared, it will never be 0. Why? X squared, the smallest value you could have for x squared is 0 when x is equal to 0. X equal to 0 implies that x squared is equal to 0. Other than that, any value of x will give you x squared that is greater than 0. So in essence, what's going to happen is that you will have always x squared greater than or equal to 0. So 5 plus x squared is going to be greater than or equal to 5 if I add 5 to both sides. Okay, this is what I get. Now, as a matter of fact, I could probably change the sign in the denominator and I could still be okay by making some changes. But let's stick to the simple case, okay? And it should work. So the denominator is never 0. Okay, so we are good. However, keep in mind that the numerator can be 0. X cubed minus 3x, it can be 0, not a problem. You could have 0 in the numerator, and in the denominator, if you have non-zero numbers, then the answer should be 0. We need to pay attention to the denominator and ensure that there is no value of x, which is going to give you 0 in the denominator. In this case, there is no value of x that will give us 0 in the denominator. So it's a well-defined function on the entire number line. So the domain for this function is going to be negative infinity to infinity, and the function is continuous everywhere. Okay, it's a rational function. So which is the ratio of two continuous function. Okay, if you have two functions f and g, both are continuous, then f divided by g is also continuous. So my f is actually maybe I should use h and g. My h is this one, okay, h the numerator and g is the denominator. Both are continuous functions because they are polynomials. Therefore the ratio is continuous and well defined in this case. I hope that this discussion was helpful. Thank you very much.